In the last video, we understood why an IP address can be invalid. We saw the problem, we deconstructed the concepts, and we solved the mystery. Now it's time to master the how. Welcome to part 2 of our first story. In this video, we'll go through 4 practical drills that will sharpen your subnetting skills. I present each problem, and I encourage you to pause the video and try to solve it before I reveal the answer. Are you ready? Let's begin. Our first drill is a fundamental one. You'll be given an IP address and a sidearm mask, and your task is to identify its boundaries. Okay, pause the video now and give it a try. Alright, let's break it down together. The key here is the /28 mask. The most direct way to solve this is to look at the last octet, 75 in binary. Now, a /28 mask means the first 28 bits are for the network. This means the first 4 bits are the network portion and the last 4 bits are the host portion. Now we just apply the rule we learned in the first video. To find the network address, we keep the network portion and set the host portion to all zeros. To find the broadcast address, we keep the network portion and set the host portion to all ones. So the network address is 64 and the broadcast address is 79. And the usable IP address range is everything in between. Let's move on to drill 2. This time, we're designing a network based on the number of devices it needs to support. To solve this without calculations, we can use a reference chart that connects the sidearm mask to the number of usable hosts. Our requirement is at least 50 devices. Looking at the usable host raw, we can see that a /27 mask only gives us 30 hosts, which is not enough. The next one, /26 mask, gives us 62 usable hosts. This is the first option that meets our requirement of 50 devices. So the most efficient subnet mask is /26. Okay, let's look at the special cases at the end of the chart using our plot of land analogy. As the sidearm number gets bigger, the plot size gets smaller. A /30 gives you a tiny plot with only 2 usable spaces, but what about /31 and /32? /32 mask gives you a plot so small, it's just a single point of land. It has only one address. This concept of a /32 mask for a single device will be important later when we talked about the host routes. So it has one usable address. A /31 mask gives you a plot with only 2 addresses. Normally, this would be useless because you'd lose both the network and the broadcast addresses. But for a path that connects just 2 points, like a private road between 2 routers, you don't need a broadcast system. A special rule allows us to use both addresses for devices. Drill 3 is the reverse. Instead of hosts, we are focusing on the number of subnets we need to create. Take a moment to work it out. Here, we start with the /16 network. We need to borrow bits from the host portion to create our subnets. The formula is 2 to the power of m, where m is the number of borrowed bits, must be greater than or equal to 100. Let's look at our power of 2. 2 to the power of 6 is 64. Not enough. 2 to the power of 7 is 128. That's more than enough to create 100 subnets. So we need to ballot 7 bits. We add these 7 ballot bits to our original network portion. Our new CIDR is /23. /23 mask in decimal is 255.255.254.0. Our final drill is the most challenging and the most realistic. We'll use variable length subnet masking or VLSM to allocate addresses for different departments with different needs. This is a great one. Pause the video and map it out. The golden rule of VLSM is to always start with the largest requirement first. In this case, that's the sales department with 100 hosts. For the 100 hosts, we'll need 7 host bits, and since the 2 to the power of 7 minus 2 is 126, that means we need a /25 network. We'll give sales the first available block. This subnet uses addresses from .0 to .127. Next up is finance with 50 hosts. For 50 hosts, we need 6 host bits, which is a /26 network. The next available address after 127 is 128. So we give finance this. This subnet uses addresses from 128 to 191. Finally, the admin department needs 20 hosts. For 20 hosts, we need 5 host bits, which is a /27 network. The next available address after 191 is 192. So we give admin this address. Now, a quick note for those with real-world experience. You are absolutely right that in the production network, we would rarely divide the subnets this tightly. In many cases, especially when using VLAN to segment the network, we might just assign a simple /24 to each VLAN for simplicity and further growth. However, for the CCNA exam, demonstrating this kind of a precise, efficient allocation with a VLSM is exactly what's required. It's a test of your understanding of the fundamentals. And there we have it. 3 departments, 3 different subnet sizes, all allocated efficiently from a single block. Okay, well done. By practicing these drills, you are not just memorizing answers. You are building the fundamental skills of a network engineer. You're learning to think in terms of blocks, bits, and boundaries. Thank you for joining the episode of Tokyo Tech Stories. I'll see you next time.